Good afternoon, students. Welcome back to chemistry class. In last class, we learned about main features of quantum mechanical model of atom and about quantum number and about principal quantum number. Today, once again, I repeat principal quantum number. Then we are going to study about azimuthal quantum number and what are the relationship between principal and azimuthal quantum number clearly. Before that, what is quantum number? The electron in an atom can be characterized by a set of 4 quantum number. The electron in an atom can be characterized by a set of 4 quantum number. What do you mean by electrons can be characterized by character? Whatever character explain the quantum number? Whatever characters? It explains about the position of electrons in an atom and what is the orientation of an electron. Orientation means direction. The direction of electrons in an orbital and then angular momentum and then energy of the orbitals. These are the characters. These characters explained by the set of 4 quantum numbers. What about 4 quantum numbers? Principal quantum numbers, azimuthal quantum number, magnetic quantum number and then spin quantum number. First upon, what about principal quantum number? Principal quantum numbers means it represents the energy level in which the electron revolve around the nucleus. It denoted by the symbol small n. Okay, principal quantum number means it represent the energy level. Okay, you know about the nucleus. The nucleus is center of the nucleus having the center of the atom having the nucleus. The electrons are revolving around the nucleus in a circular path. These circular path we called as the orbits or shells or energy levels. Okay, understood? These orbits we called as the shell, otherwise we called as orbits. Otherwise, these are the energy level. Energy level means this is the E1, first orbit, second orbit, E2, E3 and last E4. E1 means lower energy level and E4 means higher energy level. Okay, these are the energy levels. This characteristic by principal quantum number. Okay. The n is equal to 1 means n shell, whatever numbers having, whatever orbits are having the here, 4 orbits, n is equal to 1, 2, 3 and 4. And orbit or shell, 1 means K shell, 2 means L shell, 3 means M shell and 4 means N shell. Maximum number of electrons accommodated in a shell, that is explained by 2n square formula. 2n square means 2 into n square. But 2 into n square means 2 into 1 square is equal to 2. The K shell we can accommodate maximum 2 electrons. At L shell is equal to 2. L shell we can accommodate 8 electrons. And M shell we can accommodate 18 electrons. And N shell we can accommodate 32 electrons. These are about the principal quantum number. Okay. And N gives the energy of the electron. N means the energy of the electron. And how to calculate the energy of the electron? One of the formula having here. The En. En means energy of the electrons. En is equal to minus 1003 12.8 by n square into Z square joule kilojoule per mole. Here Z means atomic number. Z means atomic number. N means various energy level. N is equal to 1, N is equal to 2, maybe N is equal to 3, maybe N is equal to 4. These are the formula for calculate the energy level, energy of the electrons. Another one formula we here having Rn. Rn means this formula is to calculate the radius of the orbital. Radius of the orbital. What do you mean by radius? The distance between center of the nucleus and the outermost orbit we call as radius. Okay, what is the formula? Rn is equal to 0.529 n square divided by Z. Armstrong. Armstrong means 10 into 1 into 10 power minus 10. Okay, these are the formula to calculate the radius of the orbits. Understood? This is about the principal quantum number. Then we are going to study about azimuthal quantum number. Azimuthal quantum number. The azimuthal quantum number, it is represented by the letter L, small l. It is represented by the letter L and can take the integral values and can take the integral values from 0 to n minus 1 and can take the integral values from 0 to n minus 1. What is the integral value of L? The integral value of L means it is we can take from 0 to n minus 1. 0 to n minus 1 means the L 0 to n minus 1 we are taking n is equal to 1 means n is equal to 1 means what is the formula? 0 to n minus 1. So instead of n we are 1. We are using 1 here. So 1 minus 1 we get 0. So integral value of L to start from 0. Okay. And then when n is equal to 2, when n is equal to 2 means what is the integral value of L? N is equal to 2 means 0. They start from 0 and then n minus 1 means n is equal to 2. 2 minus 1. So we get 1. So integral value of L here, L is equal to 0 and 1. Okay, when n is equal to 3 means it's the integral value of L. We start from 0 to n minus 1. We are taking here 3. 0 to 3 minus 1. So we get 2. So integral value of L, we are taking L is equal to 0, 1, 2. Okay, and when n is equal to 4 means what is the integral value of L? Integral value is starting from 0 to n minus 1. Here n is equal to 4. So 4 minus 1 is equal to 3. So integral value of L, we are starting from 0, 1, 2, 3. These are the integral value of L. So n is equal to 1 n is equal to 1 means what is the integral value? L is equal to 0. N is equal to 2, integral value of L is equal to 0 and 1. N is equal to 3 means what is the integral value of L means 0, 1, 2. And n is equal to 4 means the integral value of L 0, 1, 2, 3. Okay, understood? These are the first point. And what about the second point? The second point, the each L value represents a subshell. Each L value means L is equal to 0, 1, 2, 3. Each L value represents subshell. The L value represents subshell. N value represents shell. L value represents subshell. Okay, when L is equal to 0, 1, 2, 3 and 4 represents the S, P, D, F and G respectively. Okay, the L value represents the subshell. Subshell means orbital. Already we studied about that orbital. Orbital means inside the orbit, having the orbital. The electrons revolve around the nucleus in a circular path. We called as the shell or orbit. Shell or orbit. Inside the orbit, orbitals are there. Or inside the shell, subshells are there. Okay, so L denotes subshell. L denotes subshell. Understood clearly? And then the maximum number of electrons. The maximum number of electrons that can be accommodated in a given subshell. The maximum number of electrons that can be accommodated in a given subshell or orbital is 2 into 2L plus 1. Maximum number of electrons can be accommodated in a given subshell or orbital is 2 into 2L plus 1. Understood? Subshell means S, P, D, F and G. Okay, what is the value of L? Integral value of L means 0, 1, 2, 3. 0 means S subshell, 1 means P subshell, 2 means D subshell, 3 means F subshell, 4 means G subshell. The each subshell, how much number of electrons we can accommodate? That is given from the one of the formula. What is the formula? 2 into 2L plus 1. Okay, so maximum number of electrons, how much? When L is equal to 0, L is equal to 0 means, what is this formula here? 2 into 2L plus 1, 2 into L value 0 plus 1 is equal to 2 into 0, 0 plus 1, 1. So 2 into 1 is equal to 2. So L is equal to 0 means maximum number of electrons 2. L is equal to 0 means what is the subshell? S orbital or S subshell. Here maximum number of electrons we can accommodate 2. Okay, and then L is equal to 1. When L is equal to 1 means how much electron we can accommodate? L is equal to 1 means P subshell. P subshell, how much number of electrons we can accommodate? Let's see. L is equal to 1. So what is the formula using here? 2 into 2L plus 1. So 2 into what is the L value? 1 plus 1. So we get 2 into 2 into 2, 2. 2 plus 1, 3. 2 into 3 is equal to 2 3s or 6 electron we can accommodated in P subshell. Okay. And when n is equal to 2. When n is equal to 2. N is equal to 2 means D subshell. How much number of electrons we can accommodated in D subshell? What is the formula? We are calculating 2 into 2L plus 1. So 2 into L is equal to 2. 2 plus 1. So we get 2 into 2 2s are 4 plus 1 5. So 2 into 2 5s are 10. D subshell we can accommodate 10 electrons. Okay, and then F subshell, that L is equal to 3. What is the formula we are calculating? 2 into 2L plus 1. So 2 into L value 3 plus 1. 2 into 2 3s are 6 plus 1 7. So 2 into 7, 7 2s are 14 electron we can accommodate in F subshell. Okay, and G subshell, maximum number of electron, the F subshell only we can calculate. Okay, and then what is the relationship between the principal quantum number and then azimuthal quantum number? What is the relationship? How will you relate the n value and L value? How will you relate? Let's see. First upon n. N denotes the principal quantum number, otherwise it denotes the energy level or orbit. Okay. The n orbit, then is equal to what is the integral value? 1, 2, 3 and 4. Whatever shells are having the n shell, the shell name, n is equal to 1 means K shell, n is equal to 2 means L shell, n is equal to 3 means M shell, n is equal to 4 means N shell. Okay. Maximum number of electrons accommodated in shell is 2n square formula in a shell. According to 2n square formula, when n is equal to 1, the K shell we can accommodate 2 electrons. When n is equal to 2, the L shell we can accommodate 8 electrons. When n is equal to 3, the M shell we can accommodate 18 electron according to 2n square formula. And then n is equal to 4 means N shell we can accommodate 32 electron according to 2n square formula. Okay, this is about the shells. And then what about the subshell? The subshell denoted by the symbol L. And here n value, how will you write the n value? When n is equal to 1, we can write n is equal to 1. The value of L we can start from 0 onwards. Okay, so because this value we can write n is equal to 1. Subshell value n is equal to 1. Okay, so first subshell, when n is equal to 1 means the first n is equal to 1 means the L value is 0. N is equal to 1 means 1 minus 1 we get 0. And second subshell means L, the value of L is n minus 1. Second shell, the n is equal to 2. N is equal to 2 means 2 minus 1, 1. And then n is equal to 3 means 3 minus 1, 2. And then n is equal to 4 means n minus 4 minus 1 we get 3. These are the subshell. L is equal to 0, 1, 2, 3. Okay, and what is the name of subshell or orbital? What is the name of subshell or orbital? 0 means s orbital. 1 means p orbital. 2 means d orbital. 3 means f orbital. Understood? So L denotes subshell. Whatever subshells are having here, 4 subshells, s orbital, p orbital, d orbital, and then f orbital. Okay, understood? And maximum number of electrons we can accommodate within the subshell. Maximum number of electrons we can accommodate within the subshells or within the orbitals. Whatever, how much electrons we can accommodate each orbitals. That is given from one of the formula. What is the formula? What is the formula? 2 into 2L plus 1. 2 into 2L plus 1. Okay, 2 into 2L plus 1 here. First, when L is equal to 0, when L is equal to 0, what is the formula? 2 into 2L plus 1. Already we calculated. So when L is equal to 0, how much electrons we can accommodate in subshell? 2 electrons. When L is equal to 1, L is equal to 1, what is the name of subshell? P subshell. How much number of electrons we can accommodate in P subshell? P subshell when N is equal to 2, L is equal to 2 means 6 electrons we can accommodate in P subshell. When L is equal to 2, when L is equal to 2, how much number of electrons we can accommodate in d orbital? L is equal to 2 means which orbital? D orbital. Maximum number of electrons we can accommodate in d orbital? 10. Okay. When L is equal to 3, L is equal to 3 means how much number of electron we can accommodate in f orbital? L is equal to 3 means what is the orbital name? F orbital. How much number of electrons we can accommodate in f orbital? 14 electron. Understood? And then we're going to write the name of subshell. Name of subshells are having within the shell. Name of subshells are having within the shell. Name of orbitals are present within the orbits. Whatever orbitals are present within the orbit, before that we should understand the integral value of L value. Integral value of L. The integral value of L we can start from 0 to n minus 1. Integral value of L we can start from 0 to n minus 1. Okay. So first 0 to n minus 1. So when n is equal to 1, when n is equal to 1, what are the integral value? When n is equal to 1 means 0 and n minus 1 means 1 minus 1, we get the 0. Okay, so first, when n is equal to 1, what is the integral value of L? 0. Okay, when n is equal to 2, when n is equal to 2, what is the integral value? We can start from 0 and 0 to n minus 2. N minus 1. N minus 1 means we are taking n for 2. So 2 minus 1 we get 1. So 0 and 1. And then third integral value of L, we can start from 0 to n minus 1. For n we are taking from now 3. N value 3. So 3 minus 1 we get the 2. So integral value of L we can start from 0 to n minus 1. N value here we are taking 3. So 3 minus 1 is equal to 2. So totally 3 integral value we get 0, 1 and 2. Understood? And the fourth one, n is equal to 4. The integral value of L start from 0 to n minus 1. For n we are taking here 4. So 4 minus 1 we get the 3. So integral value of L we are start from 0 to 3. 0, 1, 2, 3. Understood? And whatever subshells are having within the shell, here 0, first n is equal to 1 means 0. 0 means it indicates s orbital. Only one orbitals are present within the first orbit. First orbit means k orbit. K orbit, within the k orbit, s orbital is present. Okay, s orbital, total how much electrons are present? We can accommodate 2 electrons. So first orbit, k orbit, maximum number of electrons, 2 electrons we can accommodate. Okay, so here within the k orbit, which orbital is present? S orbital, maximum number of electrons 2. Understood? And second orbit, L orbit. Second orbit, that is L orbit, n is equal to 2. That is L orbit. Within the L orbit, whatever orbitals are present here, 0 and 1. 0 indicates s orbital and 1 indicates p orbital. Okay, so second orbit, that is L orbit, whatever orbitals are present, 2 orbitals. What are they? S orbital and p orbital. Okay, the s orbital maximum number of electrons we can accommodate 2 electrons, and p orbital maximum 6 electrons we can accommodate it. So 2 plus 6 totally 8 electrons. We know in L orbit maximum number of electrons we can accommodate 8 electrons. Understood? And third orbit, that is M orbit. M orbit, we know maximum 18 electrons we can accommodate it in M orbit. Whatever orbitals are present within the M orbit, whatever orbital are present within the M orbit, that is 0, 1, 2, 0, integral value of L value 0, 1 and 2. 0 indicate s orbital and 1 indicate p orbital and 2 indicate d orbital. Understood? The 2 plus 6, 8, 8 plus 10, 18. So maximum 18 electron we can accommodate it in M orbit. Understood? And then fourth one, N orbit, maximum we can accommodate 32 electrons we can accommodate it in N orbit or fourth orbit. Within the fourth orbit or N orbit, whatever orbitals are present. Here, integral value of L 0, 1, 2, 3. Okay, 0, the value of 0 indicate s orbital, value of 1 indicate p orbital, and 2 indicate d orbital, and 3 indicate f orbital. So maximum 4 orbitals we can accommodate within the n orbital. How much electron we can accommodate? S means 2 electrons, P 6 electron, 2 plus 6 8, 8 plus D maximum 10 electrons, 8 plus 10 18, 18 plus f orbital maximum 14, 18 plus 14 we can 32 electrons. Understood? So in orbit we can accommodate 32 electrons. Understood? I hope all of you understood. And about the fourth point, what is the fourth point? It is used to calculate the orbital angular momentum using the expression. It is used to calculate the orbital angular momentum using the expression. One of the expression having here, the angular momentum calculating. The formula for calculate the angular momentum is L into L plus 1 root of L into L plus 1 h by 2 pi. Okay, this is one of the formula to calculate the angular momentum of the orbital. Okay, the orbital, when electrons are revolve around the nucleus, the angle are created here. Angle are created here. The angular momentum we can calculate What is the formula? L into L plus 1 into h by 2 pi. Understood? These are about azimuthal quantum number. I hope all of you understood. So today our assignment, write the features of azimuthal quantum number. Write the features of azimuthal quantum number. Very, very important question. Principal quantum number already yesterday we studied. Some students only writing the assignment. Others didn't writing the assignment. I don't know whoever watching the class. Students, this is the time to study. Study well. Watch the video. Don't miss it. Daily portion you should study daily, and should study and write the assignment and send me through my WhatsApp number. Clear? Okay. Take, if you are having book, take page number 44. Students, take page number 44. Azimuthal quantum number, small l, or subsidiary quantum number. This is otherwise known as subsidiary quantum number. The first point, it is represented by the letter L and can take the integral values from 0 to n minus 1, where n is the principal quantum number. Point number 2, each L value represents a subshell or orbital. L is equal to 0, 1, 2, 3 and 4 represents the S, P, D and F and G orbital respectively. And third point, the maximum number of electrons that can be accommodated in a given subshell, that is 2 into 2L plus 1. 2 into 2L plus 1. And about fourth point, it is used to calculate the orbital angular momentum using the expression angular momentum is equal to root of L into L plus 1 into h by 2 pi. Understood? Thank you. Thank you all of you.